There's a sound in the room right now. Not a dramatic one. Something mechanical, probably. The refrigerator compressor cycling on, or the ventilation system doing its quiet overnight work behind the walls, pushing air through passages that you've never seen and will never think about unless something goes wrong with them. It's the kind of sound that only becomes audible when everything else has stopped. When the conversations have ended and the screens have gone dark, and the day's noise has drained out of the room like water finding a lower level, what's left is this: a hum, a texture in the silence, and the body, wherever it is, doing whatever it does when the conscious mind starts to loosen its grip on the details. That's where this starts, not with space, not with the solar system or the distances between things or any of the numbers that are waiting further along in this thought. It starts here, with the feeling of being somewhere specific, a room with dimensions, a body with weight, the particular pressure of whatever surface is supporting you right now, pressing back against the parts of you that press into it. Shoulder, hip, the back of the skull maybe, depending on how you're arranged. These are real pressures, measurable ones. The surface pushes up because the body pushes down, and the body pushes down because gravity is doing what gravity does, which is the only thing it does, pulling mass toward mass according to a relationship so simple it fits in a single equation, and so pervasive it governs the shape of everything from a raindrop to the large-scale structure of the universe. But that's getting ahead of things. Stay in the room for a moment. There's a distance between the body and the nearest wall, a few feet maybe. Depending on the size of the room, you could cross that distance in a second or two without hurrying. You know where the wall is without looking because the body has mapped the room through repetition, through the accumulation of small movements over days or months or years, building a spatial model so reliable that you could navigate it in complete darkness. You have, probably. Getting up at night without turning on a light, reaching for the door frame with a hand that knows where it is before the hand arrives. That kind of knowing. Spatial knowledge built into the muscles and the nervous system through nothing more than being somewhere long enough. Now extend that. The distance from the body to the front door. A few more seconds of walking. The distance to the street, to the edge of the neighbourhood, to the boundary of the city, wherever that is. Wherever the buildings thin out and the landscape changes character, and the word city stops being the right word for what surrounds you. Each step outward makes the previous distance feel almost nothing. The room, which seemed like a real size when you were thinking about the wall, becomes a speck against the city. The city, which seemed like a real size when you were thinking about its edges, becomes a dot on a map of the country. The country becomes a shape on a globe. The globe becomes a marble in a photograph taken from the moon. This is familiar. Everyone has seen some version of this, zooming out. The Powers of 10 film, the pale blue dot, the overview effect that astronauts describe when they see the Earth from orbit, and something in their sense of proportion permanently shifts. It's a well-worn path, this expansion of scale, and it risks feeling like a routine. Like a trick the mind has seen enough times that it no longer produces the feeling it's supposed to produce. So I want to try something different with it. Instead of zooming out to make you feel small, which is the usual move, I want to zoom out just far enough to reach the boundary of the thing we're inside. Not the Earth, not the atmosphere, not even the moon's orbit. The solar system, the actual full-sized, properly defined solar system, which is the largest structure you have ever been inside, the largest structure any human being has ever been inside, and which no human being and no human-made object has ever left. That's the thought. Not dressed up, not delivered with a dramatic pause. Just placed here in the quiet, where it can sit for a moment without needing to perform anything. You are inside the solar system. You have always been inside the solar system. Every human who has ever lived has been inside the solar system. Every footprint, every city, every war, every ocean voyage, every airplane flight, every orbit of the International Space Station, every Apollo mission to the moon, all of it, every inch of every journey any human has ever taken has occurred within a structure so large that the total distance covered by every human journey combined, all of them added together, would not constitute a meaningful fraction of its diameter. And it cannot be left, not with anything we have, not with anything we are likely to have for a very long time, not because someone is preventing it, not because there's a wall or a barrier or a locked door at the edge, but because the edge is so far away and the speeds we can achieve are so modest against it, that the word leaving starts to behave strangely when you try to apply it honestly. That's what this is about. Not the drama of confinement, not the tragedy of limitation. Something quieter than that. The specific texture of being inside something so large that inside is the only relationship available, and what that feels like when you let it settle, rather than rushing past it toward the next thought. The room is still here. The hum is still running. The weight of the body hasn't changed. Outside the window, if there is one, the night continues doing whatever it was doing before this thought arrived. Stars may be visible or they may not, depending on cloud cover and light pollution and whether you're in a place where the sky still shows itself honestly. Somewhere up there in a direction that changes with the time of year and the rotation of the Earth, the edge of the solar system exists, not as a visible thing, not as a line you could see even with the most powerful telescope, but as a region, a transition, a place where the sun's influence fades and something else begins. It's very far away. It is in fact so far away that the word far stops doing useful work and you need numbers instead. And the numbers, when they arrive, will be large enough that the mind can't hold them. As felt distances, they become symbols, placeholders for a magnitude that the nervous system has no reference experience for. But that's fine. The numbers don't need to be felt tonight. They just need to be accurate. And they are. They've been measured, estimated, cross-referenced, debated and refined by people who spent their careers trying to determine exactly how large the thing is that contains us. The answer they arrived at is strange in a specific way that's worth sitting with. The solar system is not the size you think it is. It is not even close to the size you think it is. And the reason you think it's smaller than it is has to do with a picture. A specific kind of picture that you've seen many times, in textbooks and documentaries and posters on classroom walls. A picture that shows the sun in the centre and the planets arrayed around it in their orbits, Mercury through Neptune and maybe a dotted circle for Pluto, and the whole thing fitting neatly on a single page. That picture is not wrong. The planets are real. Their orbits are real. Their relative distances, if the diagram is well made, are roughly proportional. But that picture is showing you the entryway of a building and letting you believe is the whole structure. The planets, all 8 of them, their moons, their rings, their Trojan asteroids, occupy a region of space that extends out to about 30 times the distance from the Earth to the Sun. That's Neptune's orbit. 30 astronomical units, already an enormous distance, already far beyond anything a human body could cross in a lifetime without extraordinary technology. But 30 astronomical units is to the solar system what the front porch is to a very large estate. The actual property line is somewhere else entirely. And getting there, understanding where it is and what it means, is the first thing this thought needs to do, before it can arrive at the question that's waiting at the centre of all of this, which is not how do we leave. The physics of that question has been answered. We know the speed required. We've achieved it, technically, with 5 different spacecraft. The question is stranger than that. It's about what it means that we've been leaving for nearly 50 years and we're still barely past the front door. The body adjusts, a shoulder shifts, a breath deepens slightly, or maybe it doesn't. The room holds its shape around whatever is in it, and the thought continues at whatever pace the night allows. Start with what you know, or what you think you know, which in this case might be the more honest framing. The solar system. You learned about it in school, probably around the age of 8 or 9, depending on where you grew up and what curriculum was in front of you. There was a poster, or a diagram in a textbook, or one of those models made from styrofoam balls on sticks, painted in bright colours that some kid in the class had built for the science fair and which everyone pretended to find interesting. The sun in the middle, Mercury close in, small and grey, Venus next, shrouded, Earth blue and familiar, Mars red, then the asteroid belt rendered as a dotted line or a scattering of small rocks, and beyond it the gas giants. Jupiter enormous, Saturn with its rings, Uranus tilted sideways, Neptune dark and cold at the outer edge, maybe Pluto, if the poster was old enough, sitting at the far end looking small and lonely, and not yet demoted. That's the solar system as most people carry it in their heads. 8 planets, or 9 if your sympathies run that way, arranged in concentric orbits around a star. The whole thing fitting into a mental image roughly the size of a dinner plate. A tidy thing, a knowable thing, something you could walk around in your mind the way you'd walk around a room, taking stock of where everything is and feeling like you've seen the whole of it. This picture is accurate in the same way that a photograph of a building's lobby is accurate. Everything in it is real. The proportions are roughly right. The relationships between the parts are correctly shown, and yet it gives you almost no information about how large the building actually is, because it only shows you the first room, the planetary solar system, the part with the 8 planets and the moons and the rings and the asteroid belt and all the things that made it onto that classroom poster, extends from the Sun outward to Neptune's orbit, which sits at approximately 30 astronomical units from the Sun. 1 astronomical unit, 1 AU, is the distance from the Earth to the Sun, roughly 150 million kilometres, a distance that light, moving at about 300,000 kilometres per second, crosses in approximately 8 minutes and 20 seconds. Neptune is 30 times that distance from the Sun. Light from the Sun takes about 4.5 hours to reach Neptune. That's already a number that starts to resist intuition. You can hold 8 minutes in your mind. You know what 8 minutes feels like. You've waited 8 minutes for a cup of coffee or a text message reply. But 4.5 hours of light travelling at 300,000 kilometres every second for 4.5 hours, produces a distance that the body has no reference for. It's roughly 4.5 billion kilometres. The number sits there, large and inert, communicating almost nothing to the part of the brain that understands distance through the experience of crossing it. And yet Neptune, at 4.5 billion kilometres from the Sun, is not the edge of the solar system. It is not close to the edge of the solar system. By the most commonly used scientific definition, Neptune's orbit represents less than 1/3 of 1% of the solar system's full extent. I want to let that number sit for a moment because it's easy to move past it. Less than 1/3 of 1%. The entire planetary solar system, everything you learned about in school, everything on the poster, everything in the model, fits into less than 1/3 of 1% of the structure we're inside. What fills the rest? The first thing you encounter beyond Neptune is the Kuiper Belt, a region of icy bodies stretching from about 30 astronomical units to roughly 50 astronomical units from the Sun, a wide flat disk of objects left over from the solar system's formation 4.6 billion years ago. Pluto lives here, along with several other dwarf planets, Eris, Makemake, Haumea, and countless smaller bodies, icy and dark and cold, orbiting the Sun at speeds so slow that their years are measured in Earth centuries. Pluto's orbital period is 248 Earth years. It has completed less than 1/3 of a single orbit since it was discovered in 1930. The Kuiper Belt is large. 50 astronomical units is roughly 7.5 billion kilometres, but the Kuiper Belt is still, in the architecture of the solar system close to the centre. It's still in the neighbourhood of the planets, still within the region where the Sun's light, diminished but present, provides enough illumination that objects can be photographed by spacecraft. New Horizons, the probe that flew past Pluto in 2015 and later visited the Kuiper Belt object, Arrokoth, operated in this region. It's far, impossibly far by human standards, but not far by solar system standards. Beyond the Kuiper Belt, the solar system continues. The scattered disk, a more diffuse population of icy bodies with highly elliptical orbits, extends further outward. And beyond that, much further beyond that, the density of objects drops, and the space between them widens, and the sun becomes a particularly bright star, rather than the obvious centre of everything. And you enter a region that has a name, but no clear boundaries. A region that has never been visited, never been directly observed, and is known entirely through inference and calculation. The Oort cloud. This is where the familiar picture of the solar system breaks down entirely. The Oort cloud is a theoretical structure, first proposed by Dutch astronomer Jan Oort in 1950. He was trying to solve a specific puzzle. Long-period comets, the ones that appear in the inner solar system on orbits, taking thousands or even millions of years to complete, seem to arrive from all directions. Not from the flat plane of the planets and the Kuiper belt, but from above and below and every angle in between. Their orbits suggested they originated in a vast, roughly spherical shell of material surrounding the entire solar system at extraordinary distance. That shell is the Oort cloud, and its dimensions are the thing that changes the picture permanently. The inner edge of the Oort cloud is estimated to lie somewhere between 2,000 and 5,000 astronomical units from the Sun. The inner edge, already at least 60 times farther from the Sun than Neptune, already far beyond anything any spacecraft has approached. But the inner edge is not what makes the Oort cloud remarkable. The outer edges. The outer edge of the Oort cloud is estimated to extend to approximately 100 astronomical units from the Sun. 100,000 astronomical units. To translate that into a unit that might carry slightly more intuitive weight, 100,000 astronomical units is roughly 1.6 light years. Light, travelling at its constant and absolute speed of 300,000 kilometers per second, takes about 1.6 years to cross from the Sun to the outer boundary of the solar system, and the nearest star, Proxima Centauri, is about 4.25 light years away, which means the solar system, defined by the outer limit of the Sun's gravitational influence, extends nearly halfway to the nearest star. The gap between our solar system and the closest neighbouring star system is not the vast empty gulf it's sometimes described as. It's more like the gap between two neighbouring properties whose fences almost touch. The solar system fills a much larger fraction of the distance to the nearest star than most people imagine. It fills almost 40% of it. I want to try to make this visual, not with a diagram, because diagrams flatten things and steal their strangeness, but with a comparison that might land differently. Imagine the Sun is in the centre of a city, not a small city, a large one, and the planets, all 8 of them, Mercury through Neptune, are within the first 2 blocks of the city centre. That's it. 2 blocks. The asteroid belt is in the first block. Jupiter and Saturn are in the second block. Uranus and Neptune are at the edge of the second block, peering outward. Everything you learned about in school, everything on the poster, fits within 2 blocks of city centre. The Kuiper belt extends to maybe block 3, still close, still recognisable as part of the downtown core. The Oort cloud extends to the city limits, and the city limits are 500 blocks out. 500 blocks of increasingly sparse, increasingly dark, increasingly cold territory between the bright core and the edge. No streetlights, no buildings, just the gradual thinning of the Sun's influence across a distance so large that the city centre, with all its planets and moons and rings, is invisible long before you reach the outskirts. That's the solar system, not the poster, not the model, not the classroom version with the styrofoam balls, the actual thing. A structure roughly 200,000 astronomical units across, 2 light years in diameter, defined at its outer boundary by the point where the Sun's gravitational authority gives way to the gravitational influence of the galaxy itself. Here is a detail that sharpens this further. The outer Oort cloud, the most distant region of the solar system, is only loosely bound to the Sun. Objects out there orbit so slowly that a single orbit takes millions of years. The Sun's gravity at 50,000 astronomical units is roughly 2.5 billion times weaker than it is at Earth's distance. These objects are technically in orbit around the Sun, but they are held so lightly that a passing star drifting through the galaxy on its own orbit can disturb them. The Milky Way's own gravitational tide can nudge them out of their orbits, sending some falling inward toward the Sun as long-period comets, and flinging others outward into interstellar space entirely. The edge of the solar system, in other words, is not a firm boundary, is not a wall or a fence or even a clear line. It's a region where the Sun's gravitational hold weakens to the point where external forces begin to compete with it. A transition zone, a place where inside becomes a less confident description of your position, and outside begins to apply, but gradually, without a clean moment of crossing. I want to stay with the Oort cloud for a moment longer, because it deserves something that the numbers don't quite provide. It deserves an attempt, however imperfect, to imagine what it's like out there. Not what it's like in the theoretical diagrammatic sense, what it would be like physically if you could somehow stand in the Oort cloud and look around. The first thing is the darkness. Not the darkness of a room with the lights off, where your eyes adjust and shapes emerge and the window provides a grey frame of reference. The darkness of the Oort cloud is absolute, in a way that no terrestrial experience approximates. The Sun from 50,000 astronomical units would be a bright star, brighter than any other star in the sky, certainly, brighter than Sirius appears from Earth, but not the Sun as you know it, not the disk that fills a half-degree of sky and lights the world. A point, a very bright point among millions of other points, distinguishable from them by its brightness but not by its size. The Sun's light at that distance would be too weak to illuminate anything. You would not see the ice beneath you if you were standing on one of the Oort cloud's icy bodies. You would not see your hand in front of your face unless you brought your own light. The ambient illumination of the Oort cloud is the combined starlight of the galaxy, which is real but extraordinarily dim, and the cosmic microwave background, which is invisible to human eyes. The second thing is the emptiness. The Oort cloud is estimated to contain roughly 1 trillion objects larger than 1 kilometre in diameter, and perhaps several billion objects larger than 20 kilometres. These sound like large numbers, but the volume of space they occupy is enormous. Averaged out, if you took a cube of space 1,000 astronomical units on a side, roughly the distance from the Sun to the inner edge of the Oort cloud, that cube would contain approximately 2 objects larger than a kilometre. 2 objects in a volume of space 1,000 astronomical units across. The nearest neighbour to any given Oort cloud object is, on average, millions of kilometres away. Tens of millions, possibly. The Oort cloud is, for all its trillion objects, phenomenally empty. It is a cloud in the same way that a few grains of sand in a cathedral are a collection. Technically accurate, experientially misleading. A human standing in the Oort cloud on one of its icy bodies, a lump of frozen water and methane and ammonia and dust a few kilometres across, slowly tumbling in the dark at a speed too slow to perceive, would see stars. Only stars. The sky would be full of them. The Milky Way visible as a bright band. The constellations recognisable, but very slightly shifted by parallax. And among them, one particularly bright star that was once the centre of everything. That star's gravity is still holding the ice beneath the human's feet in a very loose orbit that will take 11 million years to complete. But the holding is so light, so tenuous, that a gentle push could break it. The escape velocity from the Sun at that distance is only a few meters per second. Walking speed. You could almost step off the solar system, but you couldn't walk anywhere. The nearest object, the nearest anything, is millions of kilometers away. The darkness between one Oort cloud body and the next is total and vast, and there is nothing in it. No gas, no dust, no light except starlight. No sound because there is no medium to carry it. No temperature because temperature requires matter to measure it in, and there is almost no matter. Just vacuum. the cleanest, deepest vacuum in the solar system, deeper than any vacuum humanity has ever produced in a laboratory. A few atoms per cubic centimetre, mostly hydrogen, drifting through space so slowly that they might as well be stationary. This is the solar system. This is the part that the poster doesn't show. The vast, cold, dark, nearly empty shell that surrounds the bright inner core like the dark ocean that surrounds an island. The island is real. The island is where everything lives, but the ocean is the larger thing, and the ocean extends nearly halfway to the next island. The body in the room is on the island, deep inside the island, in the warm, lit, gravitationally dense core, where the sun's light reaches in 8 minutes and the solar wind streams outward at 400 kilometers per second, and the planets orbit in their predictable paths, and the seasons turn, and the rain falls, and the machines hum in the walls. All of that, the entire human-scale world, exists in a tiny bright region at the centre of a vast dark structure. And the vast dark structure is the solar system, properly defined. The thing we're inside, the thing we cannot leave. This is remarkably similar to what the reference script described about the edge of the Milky Way. The same quality of boundary. Not sharp, but gradient. Not a line, but a tendency. The solar system and the galaxy both end in the same way, which is to say they don't quite end. They thin. They fade. They stop being a useful word for where you are before they stop having any gravitational effect on you. There's a reason this matters beyond the aesthetic quality of fuzzy boundaries. It means that leaving the solar system is not a binary event. There is no moment at which a spacecraft crosses a line and is suddenly outside. There is instead a very long, very gradual process of moving through progressively weaker gravitational influence, through progressively thinner distributions of material, through progressively darker and quieter space, until at some point that no one could pinpoint with precision, the word inside stops applying. And by that point the spacecraft has been travelling for tens of thousands of years. The body in the room is inside all of this, not metaphorically. The room is on a planet. The planet is in orbit around the sun. The sun is at the centre of a structure 2 light years across, and the body is 1 astronomical unit from the centre of that structure, which in the proportions described above is like being on the first block of a 500-block city, close to the core, deep inside, surrounded by a volume of space so large that no human lifetime and no human technology has been sufficient to cross it. Nothing about this presses on the body. Nothing about it changes the weight of the eyelids or the temperature of the room or the sound of whatever machine is doing its quiet work somewhere in the walls. The solar system's size is not experienced. It is only known, and the knowing doesn't change the feeling of the room, which continues to feel exactly as it has always felt, contained, specific, the right size for a body, outside the night, and beyond the night the solar system vast and dark and patient, holding the planet in its orbit the way it has held the planet for 4.6 billion years, without effort, without awareness, just the geometry of mass doing what the geometry of mass does, which is to curve the space around it and let everything else follow the curves. The room is very small inside a very large thing, and the very large thing, the solar system, is itself very small inside the galaxy, which is very small inside the local group, which is very small inside the observable universe. But the layers above the solar system are not this chapter's concern. This thought stays local, stays within the sun's gravitational authority, stays inside the structure that contains everything humans have ever known, and from which nothing humans have ever built has escaped. That last claim deserves more precision, because it might sound like a poetic exaggeration, and it isn't. It's a statement of fact about 5 specific spacecraft and the specific distances they have and have not covered. And the facts, when you sit with them carefully, are stranger than the poetry. On September 5th, 1977, a spacecraft called Voyager 1 launched from Kennedy Space Center in Florida on top of a Titan III rocket. Its mission was to fly past Jupiter and Saturn, to photograph their moons and rings and magnetic fields, to send back data about the outer planets that no instrument on Earth could gather. The mission was designed to last 4 years, maybe 5. It lasted longer than that. Voyager 1 reached Jupiter in March 1979, Saturn in November 1980, and then, its primary mission complete, it kept going. Not because anyone pushed a button or issued a new set of orders, the new orders did come. It kept going because there was nothing to stop it. The gravitational assists from Jupiter and Saturn had accelerated it to a speed greater than the escape velocity of the solar system, which means it was moving fast enough that the sun's gravity, while still pulling on it, would never be strong enough to slow it to a stop and pull it back. It was on a trajectory outward, permanently outward, and it has been on that trajectory ever since. As of early 2026, Voyager 1 is approximately 165 astronomical units from the Sun. To put a number on that in a way that carries different weight, it is roughly 24.7 billion kilometers from Earth. A radio signal travelling at the speed of light takes about 23 hours to reach it. By November of this year, 2026, it will cross a milestone. It will become the first human-made object to be one full light day from Earth. 24 hours of light travel. A day's worth of the fastest thing in the universe, laid end to end, and Voyager is at the far end of it. If Mission Control in Pasadena sends a command to Voyager 1 on a Monday morning at 8 o'clock, the command arrives at the spacecraft Tuesday morning at 8 o'clock. The spacecraft processes the command and sends a response. That response arrives back at Earth Wednesday morning at 8 o'clock. A 2-day round trip, conducted at the speed of light for a conversation with an object that launched during the Carter administration. Voyager 1 is moving at approximately 17 kilometers per second, 61,000 kilometers per hour, roughly 38,000 miles per hour. This is fast by any human standard. A commercial airplane flies at roughly 900 kilometers per hour. A bullet from a high-powered rifle travels at about 1 kilometer per second. Voyager moves 17 times faster than a bullet, continuously, without stopping, without fuel, coasting on momentum acquired from Jupiter and Saturn nearly half a century ago. In the time it takes you to draw a single breath, say 4 seconds, Voyager 1 moves 68 kilometers through space. In the time it takes to read this sentence, it has moved further than most people drive in a day, and it has been doing this for 49 years, 24 hours a day, 7 days a week, for 49 years. The accumulation of that speed over that time has carried it further from Earth than any object in human history, and it is still inside the solar system. This is the fact that takes the longest to absorb, and I want to make sure it lands clearly before moving on, because everything that follows depends on understanding what it means. Voyager 1, the farthest human-made object, travelling at 17 kilometers per second for nearly half a century, has crossed roughly 165 astronomical units of the approximately 100,000 astronomical units that define the outer boundary of the solar system. That is 0.165%, less than 0.2% of the distance to the edge. If the solar system were a 100-meter running track, Voyager 1 would have covered 16.5 centimeters, about the width of your hand. At its current speed, Voyager 1 will reach the inner edge of the Oort cloud, the nearest boundary of the solar system's outermost structure, in roughly 300 years, 3 centuries from now. Long enough that the language Voyager's golden record is inscribed in may have shifted beyond recognition. Long enough that the civilization that launched it may look nothing like the civilization that exists today, and reaching the inner edge of the Oort cloud is not leaving the solar system. It's entering the solar system's largest and most diffuse region. Crossing the Oort cloud, traversing from its inner edge to its outer boundary, will take Voyager 1 approximately 30,000 years. 30,000 years. I want to sit with that number rather than rushing past it, because rushing past it is what the mind wants to do. The mind encounters a number like 30,000 years and files it under impossibly long and moves on, treating it as equivalent to any other impossibly long number. but 30,000 years has a specific weight that's worth holding for a moment. 30,000 years ago, the last ice age was in full force. Sea levels were roughly 100 metres lower than they are today. The English Channel didn't exist. You could walk from France to England. The land bridge between Siberia and Alaska was still intact, and human beings were using it to populate the Americas for the first time. No one on Earth could read or write. No one had planted a crop or domesticated an animal larger than a dog. The entire history of agriculture, of writing, of cities, of mathematics, of empires, of industry, of electricity, of flight, of computing, of space flight, all of that, the entire span of what we call civilization, fits into a window of time smaller than the time Voyager 1 needs to cross the outermost region of the solar system. And during all of that crossing, Voyager will be silent. Its power source, a radioisotope, thermoelectric generator, fueled by the radioactive decay of plutonium-238, produces less power every year as the plutonium decays. By the mid-2030s, there won't be enough power to operate any instruments at all. The last scientific data will have been transmitted, the last faint signal received by the Deep Space Network's massive antennas. After that, Voyager 1 becomes a small piece of metal and silicon and gold, roughly the size of a compact car, moving through absolute darkness at 17 kilometers per second, carrying a golden record encoded with sounds and images from a planet it will never return to, crossing a region of space so empty that the nearest object in any direction is likely millions of kilometers away. It will do this for 30,000 years, silently, in the dark, not slowing down because there is almost nothing out there to slow it, not speeding up because it has no engine and no fuel, just coasting on the kinetic energy that Jupiter gave it in 1979, through a region of the solar system that most people don't know exists, toward an edge that it will eventually cross without any instrument or any observer noting the moment. There are 5 spacecraft on solar system escape trajectories: Voyager 1, Voyager 2, Pioneer 10, Pioneer 11 and New Horizons. All 5 have achieved the speed necessary to eventually leave the Sun's gravitational influence. All 5 are heading outward on paths that will never curve back. And all 5 are still inside the solar system, deep inside it, by the proper measure. Pioneer 10 and Pioneer 11, both launched in the early 1970s, lost contact with Earth years ago. Their transmitters went silent. They are still out there, still moving, still inside, with no way to tell us where they are or what they're passing through. New Horizons, the probe that photographed Pluto in 2015, and the Kuiper Belt object Arrokoth in 2019, is currently about 60 astronomical units from the Sun, moving outward at roughly 13 kilometers per second, slower than Voyager, further behind. It too will cross the Oort cloud eventually. It too will take tens of thousands of years to do so. Voyager 2 crossed the heliopause, the outer boundary of the Sun's magnetic influence, in November 2018, about 6 years after Voyager 1, did the same in August 2012. When Voyager 1 crossed the heliopause, headlines around the world announced that it had entered interstellar space, and in a specific technical sense, this was correct. The heliopause is the boundary where the solar wind, the stream of charged particles flowing outward from the Sun at about 400 kilometers per second, finally weakens enough that the interstellar medium, the thin gas and dust that fills the space between stars, pushes back and stops it. Beyond the heliopause, the magnetic environment is no longer dominated by the Sun. The particles surrounding the spacecraft are of interstellar origin, not solar origin. But interstellar space and outside the solar system are not the same thing. The heliopause is at roughly 120 astronomical units. The solar system, defined by gravitational influence, extends to 100,000 astronomical units. The heliopause is a magnetic boundary, not a gravitational one. Voyager 1 has left the Sun's magnetic domain. It has not come close to leaving the Sun's gravitational domain. The interstellar medium in which Voyager 1 is now travelling is still inside the solar system. This sounds contradictory, and it is slightly, because the solar system has multiple boundaries depending on what you're measuring, and different boundaries give different answers to the question of where the solar system ends. If you measure by magnetic influence, the solar system ends at the heliopause, around 120 astronomical units, and Voyager has left. If you measure by gravitational influence, the solar system ends at the outer Oort cloud, around 100,000 astronomical units, and Voyager has barely started. Both boundaries are real, both are physically meaningful, neither is wrong, but the gravitational boundary is the larger and more fundamental of the two, and by that measure, the measure that determines whether an object will eventually fall back toward the Sun or drift free into the galaxy. Voyager 1 is still in the very early stages of a very long departure. There's a specific quality to this that I keep coming back to, the quality of a departure that has been achieved in principle but not in practice. The speed is sufficient, the trajectory is correct, the energy accounting works out. Voyager will leave eventually. The mathematics guarantee it. But the timeline of the departure is so extreme, so far beyond any human frame of reference, that the word leaving feels wrong. Or not wrong, but incomplete. Like describing a glacier as moving. It is moving. The physics confirms it. And yet standing in front of a glacier, you see nothing move. The motion is real and the stillness is real simultaneously. Voyager is leaving the solar system the way a glacier moves. Genuinely, physically, measurably, and also so slowly, relative to the scale of the thing it's moving through, that from any human vantage point, the departure is invisible. The solar system is that large, human speed is that modest against it. There is something else worth mentioning here, something that often gets lost in the distance numbers. The loneliness of the trajectory. Voyager 1 is heading in the general direction of the constellation Ophiuchus. It is not heading toward any particular star. In approximately 40,000 years, it will pass within about 1.7 light years of a small star called Gliese, 445 in the constellation Camelopardalis, a red dwarf about a third the mass of the Sun. It will not stop there. It has no way to stop. It will pass through that star's general neighbourhood at 17 kilometers per second and continue onward into the galaxy, on a trajectory that nothing in the foreseeable future will alter. In about 300,000 years it may pass near another star, and then another. Eventually, as it drifts through the Milky Way on an orbit of its own, a tiny metal object smaller than a school bus, carrying a golden record etched with whale songs and Beethoven and greetings in 55 languages, moving through the dark between stars at a speed that is simultaneously extraordinary and negligible, depending on what you compare it to. The room where the body rests is warm, or cool, or whatever temperature the room is, the specific temperature that the body has adjusted to and stopped noticing. The weight of the eyelids has its own small gravity. The hum continues, and somewhere out there, right now, at this moment, Voyager 1 is moving through the darkness at 17 kilometers per second, and it has been doing this for every second of every day since before many of the people who will hear this were born. It is out there now. It is always out there now. And it will not reach the edge of the solar system for another 30,000 years. That fact doesn't ask anything of the body tonight. It doesn't demand a response or a feeling. It's just a fact about the size of the place you're in, and the size of the place you're in is, by any honest measure, extraordinary. There's a number that sits at the centre of this whole inquiry, and it's worth spending some time with. Not because it's complicated. It isn't. It's one of the cleaner numbers in physics, derivable from two pieces of information: the mass of the thing you're trying to leave and your distance from its centre. Feed those in, and what comes out is a speed. A specific speed below which you cannot escape and above which you can. Escape velocity. From the surface of the Earth, the escape velocity is approximately 11.2 kilometers per second, roughly 40,000 kilometers per hour. This is the speed at which an object, launched straight up from the surface, ignoring air resistance, ignoring everything except gravity, would never fall back. Not because it outruns gravity. Gravity doesn't have a range limit. It doesn't give up at a certain altitude and let go. The object keeps decelerating the entire time, pulled back toward the Earth with a force that weakens as distance increases, but never reaches zero. But the deceleration is approaching zero at the same rate the speed is approaching zero. The two quantities thin together, neither winning. The object coasting forever through increasingly empty space, technically still slowing, technically never fully stopped. That's what escape means in physics. Not breaking free, not snapping a chain, asymptotically outrunning the deceleration. The object and the gravity locked in a mathematical relationship that approaches but never reaches a conclusion. The object never stops. The gravity never lets go. But the gap between them narrows so quickly that the object might as well be free for all practical purposes, even though it never quite is. But escaping the Earth is not escaping the solar system. The Earth sits inside the Sun's gravitational well, and to leave the solar system you must escape not just the Earth's gravity, but the Sun's. At the Earth's distance from the Sun, roughly 1 astronomical unit, the escape velocity from the Sun's gravity is approximately 42.1 kilometers per second. This is the speed at which an object, starting at Earth's orbital distance, would need to be travelling relative to the Sun to escape the Sun's gravitational influence entirely. Now the Earth is already moving. It orbits the Sun at approximately 30 kilometers per second. This orbital velocity is not wasted. A spacecraft launching from Earth in the direction of Earth's orbital motion gets that 30 kilometers per second as a free contribution. It's already moving at 30 kilometers per second relative to the Sun just by being on Earth. To reach the 42.1 kilometers per second needed for solar escape, it needs to add roughly 12 kilometers per second on top of the Earth's orbital velocity, and then there's the 11.2 kilometers per second needed to escape Earth's own gravity. The numbers combine in a specific way, not by simple addition, but by the geometry of energies, and the result is that a spacecraft launched from low Earth orbit needs a total velocity change of roughly 16.6 kilometers per second to leave the solar system. This is achievable. We have achieved it 5 times. Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons are all on solar system escape trajectories. They all received enough kinetic energy, through a combination of rocket thrust and gravitational assists from the giant planets, to exceed the solar system's escape velocity at their respective distances. But here is the thing I keep circling back to, the thing that feels worth holding carefully. Escape velocity is defined entirely in terms of the object being escaped from, not the object leaving, not the destination, not the path taken. The number comes entirely from the mass and distance of the source. The thing you are leaving writes the exit condition. Your own properties, your mass, your composition, whether you are a spacecraft or a photon or a grain of interstellar dust, none of that enters the calculation. Escape velocity is the same for everything, regardless of what's doing the escaping, which means the condition for leaving is authored entirely by what you're inside. And here's where it gets interesting. To know whether you can leave, you need to know the escape velocity. To know the escape velocity, you need to know the mass of what you're inside. To know the mass of the solar system, you need to know the mass of the Sun, which is well established at roughly 1.9 times 10 to the 30th kilograms, a number that contains 99.86% of the total mass of the solar system. The Sun is essentially the solar system, gravitationally speaking. Everything else, all the planets, all the moons, all the asteroids, all the comets, all the Kuiper Belt objects, all the Oort cloud bodies, all of it combined is less than 1/5 of 1% of the Sun's mass, which means the exit condition, the escape velocity, is set almost entirely by one object, the star at the centre. Everything else is a rounding error. The solar system's gravitational hold on you is the Sun's gravitational hold on you, and the sun's mass is known with extraordinary precision, and the escape velocity at any given distance from it can be calculated to many decimal places. The physics is clean. The number exists. The escape velocity from the sun's gravity at Earth's orbit is 42.1 kilometers per second, and this number is not controversial, not uncertain, not dependent on models or assumptions. It's a direct consequence of the sun's mass and the distance. And yet the cleanness of the number, its mathematical precision, doesn't change the fact that what the number describes is a departure measured in tens of thousands of years. The escape velocity tells you whether you can leave. It says nothing about when you'll arrive at the edge. A bullet can achieve escape velocity from a pistol shot, in principle if you're already moving fast enough, but the bullet still has to cross the distance, and the distance in this case is 100,000 astronomical units. There's an analogy here that arrives sideways, and I'm not sure whether it holds, but let me try it. Escape velocity is like knowing you have enough fuel to drive across a continent. The fuel is sufficient, the math works, the car will not run dry before it reaches the other side. But knowing you have enough fuel doesn't change the fact that the continent is 5,000 kilometers wide, and you're driving at 60 kilometers per hour, and the trip will take 83 hours even if you don't stop. The sufficiency of the fuel is real. The width of the continent is also real, and the width is the thing that determines how long you sit in the car. Voyager has enough speed. It will leave. The mathematics guarantee it. But the solar system is 100,000 astronomical units wide, and Voyager moves at 3.6 astronomical units per year, and the division of those two numbers is the thing that produces the 30,000 year timeline. The speed is sufficient. The distance is just that large. Escape velocity also has nothing to say about whether leaving is desirable. It's a purely mechanical threshold. It doesn't weigh the reasons for going. It doesn't account for what's on the other side. It simply describes the energetic cost of departure, calculated from the gravitational depth you're currently occupying. The solar system's exit price is 42.1 kilometers per second at Earth's distance, or less if you're further out, since escape velocity decreases with distance from the center of mass. No commentary on whether you'd want to pay it. No opinion on what you'd find outside. And what you'd find outside, at least for a very long time, is essentially nothing. Or rather nothing that's organized. The space between the Oort cloud's outer boundary and the nearest star system is among the emptiest regions in the galaxy. Not perfectly empty. The interstellar medium contains roughly 1 atom per cubic centimeter, mostly hydrogen. A density so low that it makes the best laboratory vacuum on Earth look like a crowded subway car by comparison. But in terms of objects, structures, things that a spacecraft might encounter or interact with, the interstellar medium between solar systems is about as close to nothing as the universe gets, which brings up the other side of the distance equation. Not just how far it is to the edge of the solar system, but how far it is from the edge of the solar system to anywhere else. The body shifts again. The room continues. The thought has been moving outward for a while now, and the outward movement is going to continue for a while longer, because the distances involved are the whole point. They are the thing that makes leaving not just difficult, but fundamentally unlike any departure a human body has ever experienced. The distances are the answer, the distances are the reason, and the distances are still getting larger. Proxima Centauri, the nearest star to the Sun, a small red dwarf, roughly 12% of the Sun's mass, too faint to see with the naked eye, located 4.25 light-years from Earth in the constellation Centaurus. It is part of a triple star system. Alpha Centauri A and B are the bright pair, orbiting each other at a distance comparable to that between the Sun and Uranus. Proxima is the third member, orbiting the pair at a much greater distance, completing one orbit every 550,000 years. It is currently the closest of the three to the Sun, and it has been the nearest star to us for about 32,000 years. It will remain so for another 25,000 years, before the geometry of stellar orbits brings another star slightly closer. 4.25 light-years. That's approximately 40 trillion kilometers, 40 followed by 12 zeros. The number communicates almost nothing to the part of the brain that processes distance through experience. You have never travelled 40 trillion kilometres. No human has travelled a meaningful fraction of 40 trillion kilometres. The total distance covered by every airplane flight, every ship voyage, every car trip, every walk taken by every human in history, added together, would be a small fraction of the distance to the nearest star. At Voyager 1's speed, 17 kilometers per second, the trip to Proxima Centauri would take approximately 73,000 years. 73,000 years. The number is sourced from NASA's own calculations, and I include that attribution not because the number needs defending, but because a number this large deserves the weight of knowing it was computed by the people who built and launched the spacecraft. 73,000 years. To put it in perspective, 73,000 years ago, modern humans existed but had not yet left Africa in the major migration that would populate the rest of the world. The supervolcano Toba had recently erupted in Sumatra, an event that some researchers believe reduced the global human population to as few as a few thousand individuals. Language as we know it may not have existed yet. Art may not have existed yet. The concept of time itself, in any form that modern humans would recognize as a concept, may not have existed yet. The entire span of recorded human history, the 5,000 years from the earliest Sumerian writing to this moment, fits inside the journey to Proxima Centauri roughly 14 times over. Even the Parker Solar Probe, the fastest human-made object in terms of peak speed, which reaches approximately 70 kilometers per second as it swoops close to the Sun in its elliptical orbit, would need more than 7,000 years to cross the gap to Proxima Centauri. And the Parker Solar Probe achieves that speed only at its closest approach to the Sun, is not heading outward, is not on an escape trajectory, it's in orbit around the Sun, and its high speed is a product of being deep in the Sun's gravity well, not of pointing toward the stars. But even if you could somehow take that speed and sustain it in a straight line toward Proxima, the trip would still take 7,000 years. Longer than the time between the building of the Great Pyramid and the writing of this sentence. The MIT Technology Review published a study examining what it would take to send a crewed spacecraft to Proxima Centauri using the fastest technology currently achievable. The researchers assumed a speed of about 700,000 kilometers per hour, roughly 200 kilometers per second, which is achievable in theory with advanced propulsion systems, but has never been sustained by any spacecraft over an interstellar distance. At that speed, the trip would take approximately 6,300 years, still far longer than any civilization has lasted. I want to be careful here. There are proposed technologies that could dramatically reduce interstellar travel times. Light sails, propelled by powerful lasers, could in theory accelerate a tiny probe to 20% of the speed of light, which would get it to Proxima Centauri in about 20 years. The Breakthrough Starshot Initiative has been studying this concept. It is real engineering, not science fiction, but it is also not built, not tested at scale, not funded for construction, and it would send a probe the size of a microchip, not a spacecraft capable of carrying anything we'd recognize as useful scientific instruments, let alone human passengers. For the foreseeable future, for any technology that actually exists and has been demonstrated, the nearest star is unreachable in any human lifetime, not because the physics is wrong. The physics works fine. The escape velocity has been achieved. The direction is known. The problem is not the physics. The problem is the gap between what physics allows in principle and what engineering has achieved in practice, multiplied by a distance so large that even the most generous assumptions about future technology produce travel times measured in centuries, and the nearest star is the nearest star. Beyond Proxima Centauri, the distances grow. The next closest star, Barnard's star, is about 6 light years away. Sirius, the brightest star in the night sky, is 8.6 light years. The stars of the Big Dipper, familiar to anyone who has looked up from the northern hemisphere, range from 79 to 124 light-years away. The centre of the Milky Way galaxy is 26,000 light-years. Each of these numbers contains more emptiness, more darkness, more quiet than the one before it, and each of them is separated from the last by vast stretches of nothing. The interstellar medium, the space between stars. The interstellar medium is not empty in the absolute sense. It contains gas, mostly hydrogen, at a density of roughly 1 atom per cubic centimetre. It contains dust, microscopic grains of silicon and carbon and iron, dispersed through the galaxy at densities so low that a cubic kilometre of interstellar space might contain a few grains. It contains cosmic rays, high-energy particles accelerated by supernova shock waves and other violent astrophysical processes threading through the galaxy at nearly the speed of light. It contains magnetic fields, weak ones, roughly 1,000th of the strength of Earth's magnetic field, but extended across light years. It is, in other words, not nothing, but it is as close to nothing as anything in the universe gets while still being something, and a spacecraft crossing it would experience its nothingness directly. No sunlight, or rather sunlight diminished to the brightness of a particularly bright star, the sun no longer a disk but a point, no longer the obvious centre of a system, but just another star in a sky full of them, indistinguishable in brightness from several of its neighbours. No solar wind, no gravitational structure to orbit, no landmarks, no waypoints, no rest stops, nothing to indicate progress except the slowly changing angles of distant stars as parallax shifts their apparent positions over centuries of travel. The emptiness has a specific quality that's worth acknowledging, not as a source of dread but as a fact about the territory. A human crossing a desert at least has ground beneath them and sky above them and a horizon to walk toward. A spacecraft crossing interstellar space has none of these. There is no ground, no sky, no horizon. There is only the faint glow of stars in every direction and the absolute silence of a vacuum that extends for trillions of kilometres in every direction. Voyager 1 is currently in the very early stages of this emptiness. It has left the heliopause, where the sun's magnetic influence ends, and entered the interstellar medium. But it is still only 165 astronomical units from the sun, which, in interstellar terms, is still standing in the sun's driveway. The true interstellar gulf, the gap between the Oort cloud's outer boundary and the nearest star system, is a span of roughly 2.5 light-years, containing, as far as any observation has determined, nothing of structural significance. The communication problem compounds the distance. Voyager 1 currently transmits data at 160 bits per second. That's roughly the speed of the earliest dial-up internet modems from the 1980s. It transmits at this speed because the signal strength, diminishing with the square of the distance, has become so faint that even the massive 70-metre dish antennas of NASA's Deep Space Network struggle to detect it. The signal Voyager sends is 23 billion times weaker than a single bar of cell phone reception. It is detected only because the antennas are enormous, and the receivers are extraordinarily sensitive, and the engineers know exactly where to point them and exactly what frequency to listen on. By the mid-2030s, Voyager's power source will no longer produce enough electricity to operate any instruments or transmitters. The plutonium-238 that fuels its radioisotope thermoelectric generators decays with a half-life of about 87.7 years, and the thermocouples that convert heat to electricity degrade over time as well. The spacecraft is already operating on a fraction of the power it had at launch. Instruments have been turned off one by one over the decades to conserve energy. The cameras were turned off in 1990, after taking the famous pale blue dot photograph. Other instruments have followed. The science return has narrowed to the essential. When the power runs out, Voyager goes silent. Not dead, exactly. The structure will persist. The golden record will remain attached to the spacecraft's body. The metal and silicon and gold will continue to exist, unaffected by the vacuum and the cold, in any meaningful way for a very, very long time. Metal doesn't rot. It doesn't decay. In the absence of an atmosphere or a corrosive environment, it just sits there. Voyager will be physically intact millions of years from now, a small inert object drifting through the galaxy, carrying a message from a civilization that may or may not still exist, but it will be silent. And the silence will last for 30,000 years as it crosses the Oort cloud, and for tens of thousands more years as it crosses the interstellar gulf, and for millions of years as it drifts through the galaxy on its own orbit, encountering nothing, heard by no one, carrying whale songs and the sound of a kiss and Chuck Berry's Johnny B. Good through the dark between stars. This is not a sad observation, or maybe it is slightly, in the way that any acknowledgement of mortality, of endings, of things that outlast the systems that created them, carries a faint charge of something. But it's also just accurate. The distances are what they are. The speeds are what they are. The result of dividing one by the other is the timeline we're looking at. And the timeline exceeds any human context for thinking about time. The body in the room is warm. The eyelids have a weight they didn't have an hour ago, or maybe they did, and it only became noticeable when the other demands on attention subsided. The room has the specific quality of late-night stillness, not silence exactly, because the hum is still there, and the body itself makes sounds, breathing and the small adjustments of position, and the faint pulse that becomes audible when everything else goes quiet. But still in the way that matters for the nervous system's transition from wakefulness to whatever comes next. The solar system is enormous. The space beyond the solar system is more enormous. The gap between these two enormities is where the word leaving runs out of energy and starts to mean something different from what it usually means. Leaving a room takes seconds. Leaving a city takes hours. Leaving a planet takes days. Leaving the solar system takes 30,000 years. At each scale the word applies. At each scale it describes something that feels less and less like the thing the world was built for. There's a thought that follows from this about what leaving actually is, about what the word contains and what it loses when applied to a structure this large. That thought has been circling since the beginning, and it's ready to land, or close to ready. As close as this kind of thought gets. The body is inside the room. This is the simplest possible statement about containment. The room has walls. The walls are material boundaries at specific locations, made of specific stuff. The inside of the room is the volume enclosed by those surfaces, and the boundary between inside and outside is, within normal tolerances, precise. You could stand in a doorway and be simultaneously almost inside and almost outside, but the ambiguity is small, a matter of centimeters, and it resolves the moment you take a step in either direction. This is what containment usually means when the word is used without qualification. A boundary that is locatable, material, and relatively sharp. Something is inside something else, because there are surfaces separating inside from outside, and the something is on the inside of those surfaces. The solar system has none of this. There is no surface, no wall, no membrane, however thin, however permeable. The solar system's boundary, to whatever extent it can be located at all, is a statistical gradient. A region where the density of objects drops, and the gravitational influence of the sun weakens relative to the gravitational influence of the galaxy, and the word inside loses confidence rather than snapping to an opposite. You could travel outward from the sun for 100,000 astronomical units, watching the Oort cloud thin around you, watching the objects become sparser, and the sun's pull become weaker, and the galaxy's tidal influence become more significant. And at no point would you pass through a surface. There would be no moment of crossing, no threshold underfoot, no change in what you can see or feel or hear, though none of those senses are relevant in interstellar space for reasons that have nothing to do with walls. The room and the solar system are not the same kind of container, that's obvious. What's less obvious and more interesting is what kind of container the solar system actually is. The body is inside the room, because the room was built around a volume of space, and the body occupies that volume. The construction preceded the occupancy. The room didn't form from the body. The body moved into a pre-existing enclosure. These are two separate things, the body and the room, in a relationship that could be dissolved at any time by the body walking out the door. The body can leave the room and remain fully itself. The room can remain fully itself with the body gone. The solar system is different in kind. The Earth didn't move into the solar system. The Earth formed from it. The solar system was a cloud of gas and dust, mostly hydrogen and helium with traces of heavier elements scattered by the deaths of earlier stars, and that cloud collapsed under its own gravity roughly 4.6 billion years ago. The centre of the collapse became the Sun. The remaining material, a flat disk of gas and dust orbiting the young Sun, gradually accreted into planets, moons, asteroids, comets, and all the other bodies that make up the solar system today. The Earth condensed out of the solar system the way a raindrop condenses out of a cloud. It didn't enter the cloud from somewhere else. It was the cloud rearranged. The atoms in the Earth's crust, the iron in its core, the water in its oceans, the carbon in every living thing on its surface, all of it was part of the solar nebula before the solar system formed. The Earth is the solar system organised at a smaller scale, a local concentration of the same material that comprises the whole structure, and the body is the Earth organised at a smaller scale still. The iron in your blood, the calcium in your bones, the oxygen you're breathing right now, all of it traces back through the same chain. The body is made of Earth material. The Earth is made of solar system material. The solar system is made of interstellar material, enriched by the deaths of previous generations of stars. The chain of origin runs from the body all the way, back through the solar system's formation and beyond, to the stellar processes that created the heavy elements the body requires. This means something specific about what containment means in this context, and I want to try to articulate it carefully rather than letting it slide into something that sounds more mystical than it is. The room contains the body the way a vessel contains a liquid. The body is a discrete thing placed inside a pre-existing enclosure. The solar system contains the body the way an ocean contains a wave. The wave is not a separate object placed inside the ocean. It is a pattern the ocean produced from itself, using its own material, following its own dynamics. The wave is inside the ocean, but it is also made of ocean, and the wave's existence is not separable from the medium it arose in. The analogy softens at the edges, the way analogies do. A wave is transient, a planet is durable, an ocean wave carries no memory of its formation. The Earth carries the chemical signature of the specific cloud it formed from, the specific epoch of galactic enrichment that produced that cloud's composition. The Earth is more individual than a wave, but the basic structure of the relationship, contained thing arising from containing medium rather than being placed inside it, holds, and this changes what it would mean to leave. A body leaving a room is a discrete object exiting an enclosure, returning to a space that is in some sense prior to and independent of the enclosure. The space outside the room was there before the room was built. It will be there if the room is demolished. The body's existence doesn't depend on the room. The room's existence doesn't depend on the body. The leaving is a clean separation of two things that were always distinct. If the solar system could be left, and hypothetically speaking, if some piece of it, a spacecraft carrying atoms forged in this system, atoms drawn from this planet, which drew them from this solar nebula, departed on an escape trajectory, it would carry with it the chemical products of the solar system's history. It would carry the angular momentum imparted by solar system dynamics during its formation. It would carry in every atom of every component the record of nucleosynthetic processes distributed across the galaxy over billions of years, concentrated into this particular solar system by the particular gravitational collapse that formed it. The departing object would leave as a piece of the solar system that had separated from the rest. not as an independent object exiting a pre-existing enclosure, but as a fragment of a larger thing attempting to exist without the larger thing. Voyager 1 is, in this framing, a tiny piece of the solar system that is gradually drifting toward the edge of the solar system. It is made of materials forged in stars that died before the sun was born, materials that were part of the solar nebula, materials that were mined from the Earth, processed in factories, assembled in clean rooms, and launched from a pad in Florida. It carries a golden record made of copper and gold, elements produced in supernovae and neutron star collisions billions of years ago, pressed into grooves by a machine built in a New York recording studio. Every atom of a Voyager is a solar system atom. Its departure is the solar system sending a small piece of itself toward its own edge. This is not containment in the room and body sense. It is something more like membership. The solar system is not surrounding the Earth the way a jar surrounds air. It is the condition for the Earth's existence, the source of its material, the shaper of its orbit, the gravitational structure within which the Earth formed and within which its physical identity was made. You cannot leave a process by carrying its products with you. The products and the process aren't separate enough for that. The solar system made the Earth. The Earth made the materials from which humans made Voyager. Voyager is departing, but it departs as a product of the thing it's leaving. The leaving, even if it's physically achieved, doesn't produce a clean separation. It produces a fragment of the solar system moving through space, taking the solar system's record with it. There's a specific fact that sharpens this. The Sun contains 99.86% of the solar system's mass. Everything else, all the planets, all the moons, all the asteroids, comets, Kuiper Belt objects and Oort cloud bodies combined, account for less than 0.14%. The solar system's gravitational identity is almost entirely the Sun, and the Sun formed from the same cloud as everything else. It didn't arrive from outside and set up shop. It was the densest concentration of the same material that became the planets, just as the planets were concentrations of the same material that became the comets, just as the comets were concentrations of the same material that fills the interstellar medium. The hierarchy is one of density and organization, not of origin. The Sun and the planets and the comets and the dust are all the same stuff, arranged at different densities and in different configurations, and the word inside, applied to this hierarchy, doesn't mean what it means when applied to a body in a room. It means something closer to a part within a whole. The Earth is inside the solar system the way a cell is inside a body, not as a separate thing enclosed by a container, but as a constituent of a structure that it is also made from. I don't want to push this further than it goes. The analogy between a cell and a body and a planet and a solar system breaks down in important ways. Cells depend on the body for their survival in a way planets don't depend on the solar system. The Earth would continue to exist, physically, if the Sun disappeared, at least for a while, drifting through interstellar space as a rogue planet, cooling over millions of years, its orbit gone but its material intact. The Earth is more independent of the solar system than a cell is of a body, but the independence is limited. Without the Sun there is no light, no heat, no photosynthesis, no liquid water on the surface, no biosphere, no breathable atmosphere maintained at habitable temperatures. The Earth's habitability is a product of its position within the solar system. Remove the solar system, and you keep the rock but lose everything that makes the rock matter. And the rock itself was made by the solar system. Its iron core was part of the solar nebula. Its water was delivered by comets and asteroids that formed in the solar nebula. Its atmosphere was built from volcanic outgassing of materials that were in the solar nebula. The Earth is, in a very specific and non-metaphorical sense, solar system material organized into a configuration that supports complexity. The containment, then, is not the containment of walls, it is the containment of origin, the containment of being made from the thing you're inside. And that kind of containment doesn't have an exit, not because the exits are locked, but because the relationship between the contained and the container isn't the kind that produces exits. You can leave a room because you are not the room. You cannot leave the solar system in the same clean way because you are, at the atomic level, made of solar system. The leaving, even if achieved, even if a Voyager drifts free of the sun's gravitational influence in 30,000 years, doesn't dissolve the relationship. It just extends it across a larger distance. The solar system's atoms arranged into a spacecraft, continuing to obey the physics they were subject to when they were part of the solar nebula 4.6 billion years ago. Conservation of momentum, conservation of energy, the same laws, the same atoms, the same physics, just further from the centre. This might sound like it's dissolving the distinctness of things, like it's arguing that because everything is made of the same underlying material, distinctions between things are illusory. That's not the argument. The Earth is real. Voyager is real. The solar system is real and distinct from other solar systems. The organisations matter. The patterns matter. The fact that a hydrogen atom in your body was once part of a molecular cloud before it was part of the solar nebula, before it was part of the Earth, before it was part of you does not make you less you, or the Earth less the Earth, or the room less a room. What it changes is the quality of the container relationship. The solar system is not surrounding the Earth from outside. It is the medium from which the Earth arose and within which the Earth's physical identity was made. That's a different kind of inside. And the pieces of that inside, the iron, the carbon, the calcium, the specific atoms now arranged into whatever is reading or listening to this, have been in many configurations before this one. They have been inside molecular clouds, inside the collapsing solar nebula, inside the early Earth's magma ocean, inside volcanic eruptions, inside ocean currents, inside the food chain, inside biology. Each configuration was inside the solar system. Each one was the solar system's matter, doing something for a while. This one is temporary too, which is not a sad observation, just an accurate one. The matter will remain associated with the solar system, or whatever the solar system becomes, long after this particular configuration has dissolved. The atoms are patient. They have been rearranging for 4.6 billion years, and they have a lot of rearranging still to do. The thought has arrived somewhere that feels like it might be near the centre of this whole inquiry. Not a conclusion exactly, more like a resting place. The solar system cannot be left because the thing doing the leaving is made of the thing being left. Not because it's impossible in the physics, though the physics makes it extremely difficult, but because even if the physics were easy, the departure wouldn't produce the clean separation that the word leave implies. You're not inside a container that someone could open. You're inside a gravitational and material relationship that produced you. The exit, such as it is an asymptotic recession from the centre of a structure that made everything about you, including your ability to conceive of leaving it. There's another dimension to this that has been waiting its turn. Not the distance to the edge and not the nature of the containment, but the motion. The motion that is happening right now, that has been happening every second of every day for 4.6 billion years, that the body does not feel, and has never felt, and will never feel. The Earth orbits the Sun at approximately 30 kilometers per second. This is a number worth sitting with, because of what it implies about the relationship between experience and reality. 30 kilometers per second, 108,000 kilometers per hour, roughly 67,000 miles per hour. The Earth is circling the Sun at a speed so great that a car travelling at highway speed would need over 1,000 years to cover the same distance the Earth covers in a single year. In the time it takes to read a single sentence at a comfortable pace, maybe 5 seconds, the Earth has moved 150 kilometers, roughly the distance from one small city to another. By the time you finish a paragraph, you've moved 1,000 kilometers. The distance from New York to Chicago, traversed in the time it takes to read a few hundred words, and you feel none of it. The body reports nothing. No wind, no pressure, no sensation of motion. The vestibular system, the balance organs in the inner ear, responds to acceleration, to changes in velocity, not to velocity itself. the Earth's orbital speed is so nearly constant, the curve of its orbit so gentle at this radius, that the acceleration involved is far below the threshold of human perception. You are moving at 30 kilometers per second, and the nervous system classifies this as stillness. But 30 kilometers per second is only one layer. The Earth orbits the Sun, and the Sun orbits the galaxy. The Sun's orbital velocity around the centre of the Milky Way is approximately 220 kilometers per second, 7 times faster than the Earth's orbital velocity around the Sun. The Sun, carrying the entire solar system with it, all the planets, all the moons, all the asteroids and comets and Kuiper Belt objects and Oort cloud bodies, is hurtling around the galaxy at 220 kilometers per second. One complete orbit takes approximately 225 million years. The Sun has completed about 20 of these orbits in its lifetime, 20 galactic years, each one spanning the rise and fall of entire geological periods on Earth. The last time the Sun was in this approximate position in its galactic orbit, 225 million years ago, the Triassic period had not yet begun. Dinosaurs had not evolved. The continents were arranged in a single supercontinent called Pangaea. The atmosphere had a different composition. The ocean chemistry was different. Life on Earth looked nothing like it does today. The Sun returned to roughly this position after completing one orbit around the galaxy and found a planet with humans on it. A planet that had changed almost beyond recognition in a single galactic year. And layered on top of the Sun's galactic orbit, there is another motion. The Milky Way itself is moving. The galaxy containing the Sun, containing the solar system, containing the Earth, containing the room, containing the body, is moving through the universe at approximately 600 kilometers per second relative to the cosmic microwave background, the faint thermal radiation left over from the early universe that fills all of space. This is the deepest layer of motion, the final contribution to the total velocity of everything on Earth, 600 kilometers per second. The solar system, nested inside the galaxy, nested inside the local group of galaxies, streaming toward a massive gravitational concentration called the Great Attractor in the direction of the constellation Centaurus. Added together as vectors, accounting for directions, the total speed of the solar system through space, relative to the cosmic microwave background, is approximately 370 kilometers per second. The exact direction varies as the Earth orbits the Sun and the components shift their geometric relationships, but the magnitude is roughly constant, and the body's awareness of it is exactly 0. 370 kilometers per second. In the time it takes to blink, a genuine blink, the involuntary kind that lasts about 300 milliseconds, the solar system moves about 111 kilometers. In the time between one heartbeat and the next, roughly 800 milliseconds, the solar system moves about 296 kilometers. In the time it takes to fall asleep, maybe 15 or 20 minutes if tonight is a good night, the solar system moves roughly 400,000 kilometers. The distance from the Earth to the Moon, traversed during the transition from wakefulness to sleep, and the transition reports nothing. What does stillness mean then? Not rhetorically, as a genuine question about the relationship between the body's experience and the physical situation the body is embedded in. The body feels still. The room is still. The surfaces are stable. The air is calm or close to calm, with whatever minor drafts the building's ventilation creates. The weight of the body presses downward in the familiar way, and the surface presses back, and the result is the specific sensation of rest, of being somewhere, of not moving. This is real. The stillness is not an illusion that the velocity exposes as false. The velocity doesn't unmask anything. The body is still at the scale of the room. The room is still at the scale of the building. The building is still relative to the ground. The ground is rotating with the Earth, orbiting with the solar system, streaming with the galaxy, and none of the larger motions produce a sensation, because sensation requires acceleration, and the motions are so nearly constant that the accelerations involved fall below the threshold of any human sense organ. The two conditions, bodily stillness and cosmic velocity, are simultaneously true. They operate at different scales, different reference frames, different levels of description of the same situation. The body doesn't need to reconcile them. It can hold both and continue resting. The stillness is for the body. The velocity is for the physics. Both are real, and neither cancels the other. But knowing about the velocity does something to the quality of the stillness, doesn't it? Not something dramatic. Not something that changes the physical experience, more like an additional texture layered underneath the familiar one. The way knowing the history of a house changes the feeling of standing in it. Even though the floorboards and the light and the temperature are all exactly the same as they were before you knew. Knowledge doesn't change sensation, but it does change the experience of sensation. The body resting in a room is simultaneously participating in at least 4 distinct motions. The rotation of the Earth on its axis, roughly 0.46 kilometers per second at the equator, slower at higher latitudes. The orbit of the Earth around the Sun, 30 kilometers per second. The orbit of the Sun around the galactic center, 220 kilometers per second. And the streaming motion of the galaxy through the universe, contributing to a total of roughly 370 kilometers per second relative to the cosmic microwave background. None of these motions are new. They have been happening for as long as the solar system has existed. Every human who has ever lived has been participating in all of them simultaneously. Every dinosaur, every trilobite, every bacterium that has ever existed on this planet has been moving at 30 kilometers per second around the Sun and 220 kilometers per second around the galaxy and 370 kilometers per second through the universe, and none of them knew it. None of them could have known it. The awareness is recent, a product of the last few centuries of astronomical observation and the last few decades of precision measurement. The condition is 4.6 billion years old. The solar system carries everything it contains at these speeds. The Oort cloud, 100,000 astronomical units from the Sun, is moving with the Sun at 220 kilometers per second around the galaxy. The entire structure, the Sun and the planets and the Kuiper Belt and the Oort cloud, is one coherent system moving through the galaxy as a unit. The gravitational bonds that hold the solar system together are strong enough, at these scales, that the entire system acts as a single entity for the purposes of galactic orbital mechanics. The Oort cloud does lag slightly behind the Sun in the direction of the solar system's motion through the interstellar medium, compressed on the leading edge and stretched on the trailing edge by the interaction with the galactic environment. But it moves with the Sun. It is part of the system. It travels. And the body deep inside this system, at 1 astronomical unit from the centre, feels none of the travel. The body feels the room. The body feels the weight. The body feels the temperature and the texture of whatever surface it's resting on, and the particular quality of the air, and the sound of the hum, and the heaviness of the eyelids, and all of the small specific signals that the nervous system processes when it is trying to transition from wakefulness to rest. These are the signals that matter to the body. The 370 kilometers per second is a fact about the physics, not about the experience, and the body correctly ignores it. But the fact persists. And the fact has a specific quality when you sit with it long enough, which is that you are never not moving. There has never been a moment of genuine stillness in the absolute sense in the entire history of the Earth. The planet has been orbiting the Sun, and the Sun has been orbiting the galaxy for the entire time anything has existed on the surface. The rest you feel is real, but it is rest in one reference frame, while the reference frame itself is in motion in another reference frame, and that reference frame is in motion in another, and so on, up through the layers. Stillness, at the deepest level physics can describe, doesn't exist for anything in the universe. Everything is moving relative to something. The cosmic microwave background provides the closest thing to a universal rest frame, and even it is not a privileged frame in the sense that physics allows. It's just the most convenient one for measuring large-scale velocities. Against it, The solar system moves at 370 kilometers per second. Against the galactic center, it moves at 220 kilometers per second. Against the Sun, the Earth moves at 30 kilometers per second. Against the Earth, the body moves at whatever speed it's moving, which right now is approximately 0, which is the only number that matters for the experience of rest. The solar system is, among other things, a very fast vehicle that doesn't feel like a vehicle. It is carrying everything it contains, the Sun and its entire gravitational family, through the galaxy at speeds that would be terrifying if they produced any sensation, and it will continue doing this for the rest of the Sun's life, roughly 5 billion more years, and beyond, as the Sun's remnant, a white dwarf, continues to orbit the galactic center on essentially the same trajectory, carrying whatever remains of its planetary system along with it. The body doesn't need to do anything with this. It is, if anything, an argument for rest. The largest motions require the least effort. The solar system crosses the galaxy without trying. The galaxy streams through the universe without exertion. The body can rest without guilt, because the largest structures in the universe are already doing the moving, and they don't need any help. There is a future to this structure. The solar system has a timeline, and the timeline has stages, and the stages unfold at paces so slow they make a Voyager's 30,000-year crossing look hurried. The Sun is currently 4.6 billion years old. It is a main sequence star, meaning it is in the stable phase of its life where it fuses hydrogen into helium in its core, producing the energy that lights and heats the solar system. This phase will last approximately another 5 billion years. The Sun is, in stellar terms, middle-aged. Roughly halfway through its expected lifetime, it has been burning steadily for longer than the Earth has had multicellular life on its surface, and it will continue burning steadily for longer than multicellular life has existed so far. But it will not burn forever. In approximately 5 billion years, the hydrogen in the Sun's core will be exhausted. The core will contract, heating up as it does, and the outer layers will expand enormously. The Sun will swell into a red giant star, its diameter growing to perhaps 200 times its current size. Its surface will engulf the orbits of Mercury and Venus. Whether it will engulf the Earth is a question that depends on details of mass loss during the expansion, and the current best estimates are uncertain. It may just barely reach the Earth's current orbit. It may fall short. In either case, the Earth's surface will be sterilized long before the expansion reaches it. The increased luminosity of the swelling Sun will evaporate the oceans and strip the atmosphere hundreds of millions of years before the physical expansion arrives. After the red giant phase, which lasts perhaps 1 billion years, the Sun will shed its outer layers in a planetary nebula, a shell of glowing gas expanding outward into space. What remains will be the core, a white dwarf, a dense, slowly cooling object roughly the size of the Earth but containing about half the Sun's original mass. No longer fusing anything, no longer producing energy except the slow radiation of stored heat, a remnant. The white dwarf will continue to orbit the galactic center. It will continue to exert gravitational influence on whatever objects remain in its vicinity. The Oort cloud, or what remains of it after billions of years of perturbation by passing stars and the galactic tide, will still be loosely associated with the dying star. The Kuiper belt may still exist in some diminished form. The outer planets, Jupiter, Saturn, Uranus and Neptune, will likely survive the Sun's red giant phase largely intact, though their orbits may be perturbed by the Sun's mass loss. They will continue orbiting the white dwarf in the dark, unlit except by starlight from other suns. The solar system, in other words, will persist. Not as it is now, not as the bright, warm, planet-filled structure that supports liquid water and biology in rooms with humming machines and bodies at rest, but as a gravitational structure, a collection of objects bound to a remnant star, orbiting in the dark, carrying the chemical record of everything that happened here for the first 10 billion years. The white dwarf will cool over trillions of years, not billions, trillions. White dwarfs radiate their stored thermal energy so slowly that the cooling timescale exceeds the current age of the universe by orders of magnitude. No white dwarf in the observable universe has yet cooled to the theoretical endpoint. A black dwarf, a cold, dark, inert remnant emitting no detectable radiation. The universe is not old enough. Every white dwarf that exists is still warm, still radiating, still visible to instruments that can detect their faint glow. Eventually, on timescales so long they resist meaningful description, the white dwarf that was once the sun will cool to near absolute zero. The planets, if they remain in orbit, will be frozen, dark objects circling a dark remnant in a galaxy that is itself slowly running out of stars. The last red dwarfs in the Milky Way will still be burning. Those tiny, cool, dim stars that fuse hydrogen so slowly, they can burn for trillions of years, but even they will eventually exhaust their fuel. And when the last red dwarf goes out, the era of stars, the stelliferous era, the period in which the universe produces light through nuclear fusion, will end. The solar system's remnant will be part of that darkness. A white dwarf, possibly blackened by then, orbited by frozen planets and the scattered debris of the Oort cloud, still gravitationally coherent, still a system, still inside the galaxy. The gravitational bonds don't care about light. They don't require energy. They persist as long as the mass persists, and the geometry of space-time continues to curve around it. The solar system's matter will still be here, still bound, still orbiting, long after the last photon of starlight has been emitted by the last star in the galaxy. This is the long future of the thing you're inside. Not destruction, not dissolution, transformation. The solar system will change, profoundly and irreversibly, but it will not cease to exist as a gravitational entity. The sun will become a white dwarf. The planets will go dark. The Oort cloud will thin. But the mass will remain, and the gravity will remain, and the orbits will remain, and the word inside will continue to apply to whatever is still associated with the remnant of the sun. The body in the room will not be here for any of this. That's obvious, but it's worth stating. Not as a source of sadness, but as a calibration. The human lifespan is roughly 80 years. The solar system's remaining main sequence lifetime is 5 billion years. The ratio between these two numbers is the same as the ratio between a single heartbeat and a full year. A human life is to the solar system's remaining lifetime what a heartbeat is to a year, a brief pulse within a much longer rhythm, and the longer rhythm will continue after the pulse, not because it's indifferent to the pulse, but because its timescale operates at a different order of magnitude. The atoms in the body, however, are not on a human timescale. They are on a stellar timescale. The iron atoms in the blood existed before the sun formed. They will exist after the sun dies. They will circulate through whatever configurations the solar system's matter assumes in the billions and trillions of years after the white dwarf cools, incorporated into new structures or dispersed into the interstellar medium, or captured by other star systems, or simply drifting through the galaxy as free atoms, unbound, patient, carrying no memory of the configurations they once participated in. The body is a temporary configuration. The atoms are not temporary. The solar system is a temporary configuration too, in the longest view. A gravitational structure that will eventually lose its coherence as dynamical interactions over trillions of years scatter its components. But temporary at that scale means lasting longer than almost anything the human mind can conceive of. The solar system will persist in some form for longer than the stars. The thought has gone a long way from the room. It has been out past Neptune, past the Kuiper Belt, past the heliopause into the Oort cloud, across the interstellar gulf, forward in time to the death of the sun and beyond. It has been travelling in its way, the same direction Voyager is travelling, outward and forward, toward boundaries that keep receding and timelines that keep extending. But the body hasn't moved. The body is exactly where it was when this thought began. In a room, on a surface, under whatever weight the eyelids carry at this hour. The distance between the body and the edge of the solar system hasn't changed. The distance between the body and the death of the sun hasn't changed. These numbers are what they are, and they will be what they are tomorrow, and the day after that, and for a very long time after that. The thought can come back now. It has been out long enough. The room is waiting, and the room is a good place to be, and the solar system is content to hold everything it holds without requiring anything from the bodies inside it. It has been holding them for 4.6 billion years. It is good at it. Begin where this started. A room, a body in it, the ordinary weight of things pressing down in the ordinary way, the hum that has been there the whole time, the one you stopped noticing and then noticed again and then stopped noticing again, doing what background sounds do, which is to be present without requiring attention. The body has settled, probably, into whatever configuration it finds most sustainable for rest. The small negotiations between joints and surfaces have mostly concluded. The temperature has been accepted. The blanket or the sheet or whatever covers the body has stopped being a separate thing and become part of the body's thermal envelope, an extension of its warmth, no longer noticed as a distinct object. This is the room. This is the specific place where this inquiry has been conducted, if conducted is the right word for something that moved more like a current than a project, not directed so much as followed, not argued so much as walked through slowly, in the dark, at the pace the dark allows. And outside the room, through the walls and the window, and the roof and the atmosphere and the space between here and there, the solar system continues being what it is. 100,000 astronomical units of gravitationally associated matter centered on a middle-aged star, containing 8 planets, several hundred moons, millions of asteroids, billions of comets, and one civilization that has been aware of its own containment for less than a century. That last part is worth pausing on, not the containment, which has been the subject of this entire meditation, but the awareness of it. The awareness is new, profoundly new. For the vast majority of human history, the solar system was not a concept. The sun was the sun, the moon was the moon, the stars were the stars. The idea that all of these were part of a single gravitationally bound structure, that the Earth was one of several planets orbiting the sun, that the sun was one of hundreds of billions of stars in a galaxy, that the solar system had an edge and a size and a shape, all of this is recent knowledge. Copernicus published his heliocentric model in 1543. Kepler described the planetary orbits in the early 1600s. Newton published the law of gravitation. In 1687, Jan Oort proposed the existence of the Oort cloud in 1950. Voyager 1 crossed the heliopause in 2012. The entire history of knowing what the solar system is and how large it is fits within a few centuries. Before that, humans lived inside it without knowing they were inside it. The way a fish lives inside water without knowing it's inside water. The containment was the same. The physics was the same. The impossibility of leaving was the same. The only thing that has changed is the awareness. And the awareness, as far as the physics is concerned, changes nothing. The body is held by the same gravity it was held by before anyone understood gravity. The solar system is the same size it was before anyone measured it. The awareness is a property of the mind, not of the structure, and the structure persists identically, whether the mind is aware of it or not. There's something almost restful about that, about the fact that the solar system's hold on everything it contains is not a relationship that requires awareness to function. You don't have to understand gravity for gravity to work. You don't have to know the escape velocity for the escape velocity to apply. You don't have to hold in your mind the distances between here and the Oort cloud for those distances to exist. The containment operates autonomously, the way a heartbeat operates autonomously, the way breathing operates autonomously once the conscious mind stops trying to control it. The solar system holds the Earth in its orbit without effort, without intention, without awareness. It is simply what mass does in the presence of other mass. Curvature, geometry, the oldest and simplest physical relationship in the universe, playing out at a scale that happens to include your body and your room, and your city and your planet, and your entire species within it. The solar system doesn't know you're inside it. It doesn't know anything. It's not a knower. It's a structure. A pattern of mass and motion that has persisted for 4.6 billion years because the physics that created it continues to operate. And the physics will continue to operate after you've fallen asleep tonight, and after you've woken up tomorrow, and after every day that follows, until the sun exhausts its hydrogen and swells and contracts and cools, and the structure changes form but doesn't disappear, and the matter rearranges but doesn't leave. Here is the thing I keep coming back to. Not the distances, though the distances are real and extraordinary. Not the timescales, though the timescales are beyond any human frame. Not the physics, though the physics is clean and settled and not subject to opinion. The thing I keep coming back to is the quality of the relationship. The specific texture of being inside something you didn't choose, can't leave, arose from, are made of, and will return to. It isn't imprisonment. Imprisonment requires a captor, a boundary maintained by intention, an interior that could in principle be an exterior if the lock were opened. The solar system has none of these. There is no captor. There is no lock. There is no maintained boundary. The gravitational hold is not an act. It is a condition, a consequence of mass existing in proximity to other mass. The sun doesn't hold the earth the way a jailer holds a prisoner. The sun holds the earth the way mass holds mass, which is to say automatically, impartially, without any quality of restriction that the word hold usually implies. And it isn't limitation in the way that word usually feels. Limitation usually carries the sense of being less than, of being unable to achieve something that is, in principle, achievable, of falling short. But the solar system's size is not something you fall short of crossing. It's not a challenge you could meet with better technology or more determination. The distances are simply too large for any technology humanity has produced or is likely to produce in the foreseeable future. And the distances don't feel like a barrier because they don't present themselves. They don't stand in front of you. They're not visible, they're not experienced. They exist only in the numbers, and the numbers exist only when someone calculates them. The solar system's boundary is the quietest kind of boundary, the kind that only exists when you look for it, the kind that doesn't resist crossing because it doesn't need to. The distance does the work. The distance is the boundary. Not a wall, not a fence, not a force field, just space, an extraordinary amount of space. More space than any human journey has ever crossed. More space than Voyager has crossed in half a century of continuous travel. Space that is empty and dark and cold and patient and absolutely indifferent to whether anything crosses it or not. The body knows none of this. The body knows the room. The body knows the weight of the eyelids and the pressure of the surface beneath it, and the temperature of the air and the quality of the silence. The body knows what it needs to know for the task at hand, which is rest, and the rest is available. The rest is not prevented by the distances, or the velocities, or the 30,000-year crossing times, or the eventual death of the sun. These facts coexist with rest. They are the background conditions under which rest occurs, the way the rotation of the Earth is the background condition under which day and night occur. True, constant and irrelevant to the experience of the moment. The solar system will be there in the morning. It has been there every morning since there were mornings. It will be there for 5 billion more years of mornings, and on each of those mornings, the light that enters the window or doesn't enter the window or doesn't exist, because there is no window, will be light from the same star that sits at the centre of the same structure that contains everything on the poster, and everything not on the poster, and the poster itself and the wall, the poster hung on, and the building the wall was part of, and the city the building stood in, and the planet the city was built on. All of it inside the solar system, all of it made of the solar system's material, all of it held by the solar system's gravity, all of it moving at the solar system's speed through the galaxy, at 220 kilometers per second, silently, without sensation, while the body rests. You don't have to hold this. You don't have to remember it. You don't have to carry it anywhere. It is not information that requires action. It is not a problem that requires solving. It is not a tragedy that requires mourning. It is a description of the place you are in, and the place you are in is, by any honest measure, remarkable, not because it's unusual. Every star in the galaxy has its own version of this structure, its own gravitational domain, its own Oort cloud equivalent, its own collection of orbiting matter. The solar system is, among star systems, ordinary. What's remarkable is the awareness. The fact that one of the objects orbiting this particular star has produced a species capable of understanding the structure it lives inside, capable of measuring the distances, capable of launching a spacecraft toward the edge, capable of lying in the dark at night and thinking about what all of it means. The awareness doesn't change the physics, but it does something to the experience of the physics. Knowing that the room is inside the solar system doesn't make the room larger, but it does make the word inside carry more weight, more layers, more depth. You are inside the room. The room is inside the building. The building is inside the city. The city is inside the country. The country is on the planet. The planet is inside the solar system. The solar system is inside the galaxy. And at each level, the word inside means something slightly different, shifts its weight, adjusts its connotation. Inside the room means enclosed by walls. Inside the solar system means gravitationally associated with a star. These are different kinds of inside, and they are both true simultaneously, layered, nested, each one invisible from within the one it contains. The thought has been with you for a while now. It arrived without being summoned, or maybe it was summoned by the quiet, by the specific quality of nighttime attention that goes where it wants rather than where it's directed. It has travelled outward from the room to Neptune and beyond, to the Oort cloud and the interstellar medium, and the nearest star in the far future and the deep past. It has asked a question, why you can never leave the solar system, and arrived at answers that are part physics and part something else, something that doesn't have a clean name, but that has to do with the relationship between a thing and the thing it's made of. The answer, insofar as there is one, is this: you cannot leave the solar system because you are not separate from the solar system. Your atoms were forged in stars that predated the sun. Those atoms were incorporated into the solar nebula. The nebula collapsed into the sun and the planets. The planets produced the conditions for biology. The biology produced you. You are the solar system organized at a very small scale, in a very specific configuration, for a very brief time. Leaving the solar system would require being something other than what you are, and you are not something other than what you are. You are this specific arrangement of solar system matter, in this specific room, at this specific moment, thinking this specific thought. The thought is settling now, not because it's finished. This kind of thought doesn't finish. It thins. It quiets. It moves from the foreground to the background, where it joins the hum and the weight and the temperature and the darkness as part of the texture of the night. It doesn't need resolution. It doesn't need a moral or a lesson or a takeaway. It's just a thought about where you are, and where you are is inside a structure that made you, from material that was here before you and will be here after you, held by a gravity that asks nothing and provides everything necessary for the room to exist and the body to rest, and the night to continue doing whatever it does while the mind drifts towards sleep. The solar system doesn't need you to think about it. It will continue whether you do or don't. It will hold the Earth in its orbit and carry the planets through the dark, and keep the Oort cloud loosely associated at its outer boundary, and send the occasional comet falling inward toward the sun. A reminder that the far edges of the system are still out there, still connected, still part of the whole. And Voyager 1, out there somewhere in the dark, at 165 astronomical units and counting, is still moving, still crossing the solar system at 17 kilometers per second, heading toward an edge it will reach in 30,000 years. It carries a golden record with whale songs and Beethoven, and greetings in 55 languages from a species that built it from the materials of the planet that formed from the star that sits at the center of the system it's trying to leave. The golden record is made of solar system matter. The greetings are spoken by solar system matter. The whale songs were produced by solar system matter. Every atom of a Voyager, every atom of the record, every atom of everything was part of the original cloud, and the cloud became the system, and the system is what it is, and Voyager is leaving it the way a wave leaves the ocean, which is to say, not quite, not cleanly, not in a way that produces a thing that is fully separate from the thing it came from. The room is dark, or nearly dark. The light from the window, if there is a window, does whatever it does. The body has its weight. The gravity is present. The solar system is present, though present is doing different work here than it usually does. Present in the way that the ground is present beneath a building, not visible, not noticed, not experienced, but supporting everything, holding everything, providing the structural condition for everything above it to exist in the configuration it exists in. The ground doesn't need to be thanked for supporting the building. The solar system doesn't need to be thanked for containing the planet. These are not acts of generosity. They are conditions of physics, and the conditions are stable. They have been stable for a very long time. They will be stable for a very long time to come. The body can rest inside them without worry, without effort, without needing to understand them, the way it rests inside the room without thinking about the room's structural engineering. The thought is quiet now. The distances are still there, but they've been placed somewhere that doesn't interfere with rest. The 100,000 astronomical units to the edge. The 73,000 years to the nearest star. The 30,000 years to cross the Oort cloud. The 5 billion years until the sun changes. These numbers exist in the same way the stars exist. Present. Real. Not pressing on anything. The body settles. The eyelids, if they haven't already, find their natural weight. The breathing shifts, maybe, toward the slower rhythm that precedes sleep. The room holds its shape. The hum continues. And the solar system, vast and dark and patient, holds the room the way it holds everything. Not with walls, not with effort. Just with mass. Just with the geometry of space-time curved by a star and everything that orbits it. You are inside this, you have always been inside this, and the inside is not a cage. It is a place. The place that made you. The place that holds you.